Okay, so I'd like to look at one example completely from start to finish, and it has a little bit of added twist to it to have you fully feel good about all of the rational zero theorem, the factor theorem, the division, everything that you need to do to be able to find zeros or fully factor a polynomial. Okay, so take a look at this example. So we're going to find a zero of f of x equals x cubed minus 3x squared minus 2x plus 2. So we know nothing about this polynomial so far, so we'd like to figure out what are some zeros that might be nice zeros for us. So we're going to use our rational zero theorem. So we have our rational zero theorem. We're going to make a list of all of the possible rational zeros. So what we look at is we look at factors of the constant term. So our constant term is 2, so our only factors are plus or minus 1, plus or minus 2. And then we look at factors of the leading coefficient. And the only factors of 1 are going to be plus or minus 1. So we have the only possible rational zeros. So the only possible rational zeros are going to be plus or minus 1 or plus or minus 2. Because remember, we take the constant, those are the numerator, the denominator is found by the leading coefficients of the factors of the leading coefficient. So as a note, if you notice from our previous examples, if this is ever 1, then the only possible rational zeros are just factors of the constant term. We looked at another example where this wasn't a 1, and then we have more bizarre looking fractions. But most of the time, if this is a 1, then it's just going to be the easiest type of approach to it. So once we know our possible rational zeros of this, now we try to figure out which one of these, if it is a 0, is going to work for us. So we're going to check each of these numbers, plug in 1, see if that works, plug in -1, 2, -2, all of those, until you find 1. Once you find 1, then we're going to be good to start our division. So in this case, what we could check is you could check f of -1. Try -1, you're going to get a -1, a -3, plus 2, plus 2. This will give us a 0. So what we see here in this case is that we see x equals -1 is a 0. So then by the factor theorem, what this also then implies is that x plus 1 is a factor. So now that we know this, we can now start our long division, or I guess just any old division. So we're going to divide our polynomial x cubed minus 3x squared minus 2x plus 2. We're going to divide this by x plus 1 and figure out what does that equal. So we'll set up, again, I'm going to use synthetic division. We put -1 in our box. We have our coefficients of 1, -3, -2, and 2. We bring down the first number, we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and then we add. And so these numbers form the coefficient of our quotient. So we have x squared minus 4x plus 2. So this is what our division is, but then if we would like to again, write this as a factored form, this is going to say that x cubed minus 3x squared minus 2x plus 2 is equal to x plus 1 times x squared minus 4x plus 2. So this is looking good, right? So we've seen this multiple times now, and then at this point now we're trying to figure out what multiplies to 2 and adds to -4. Now the only things that multiply to 2 are going to be +1, +2, -1, -2, and that's it. None of those are going to add to -4, so this is where we have to get a little bit more creative. We are going to try to figure out how else can I find the zeros of this, right? Because if I could find the zeros of this, then I'll find the zeros of the original polynomial. So the only technique we have is we have the quadratic formula available to us. So we will use the quadratic formula. So we'll have our x, again, Quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So this becomes 4 plus or minus the square root of negative 4 squared minus 4 times our coefficient of x squared times our constant term divided by 2. So x is going to be 4 plus or minus the square root. This is 16 minus 8. This gives us an 8 divided by 2. So x is going to be 4 plus or minus. If you'd like to simplify the square root of 8, remember, you can simplify square roots by figuring out what multiplies to the number below, where one of them is a nice square. So this would be the square root of 4 times the square root of 2. So x is going to be 4 plus or minus 2 square root of 2. And we do all of that because we're going to be able to cancel off, we're going to be able to cancel off 2's in both of these. So our final answer is going to be 2 plus or minus the square root of 2. So these are the zeros of this polynomial of x squared minus 4x plus 2, and then the only other zero we have is the one from that. So if we want to find all of the zeros of this, then we see the only zeros we have is x is equal to negative 1, and then 2 plus or minus the square root of 2. So we have this forms a zero of negative 1, and this forms a zeros of 2 plus or minus the square root of 2. So again, don't be afraid of the quadratic formula. That is going to be a very good technique if we need it in the midst of our problem.